Hello everyone. Good afternoon. Good afternoon, JNB Ramnagar students. Am I audible and visible to you guys? Can you able to see me? No? Am I audible? Am I audible and visible now? Can you be able to see my screen? Yes. Okay. So let's continue with today's session. So I hope yesterday Vivek sir have started with the redox reaction part, right? So we will just continue that. So the main important topics in redox reactions are, just a second. Yeah. So these are the 7 topics we will cover here in this lesson. Okay. So majorly the definition part of redox and the types of redox reaction you might have seen tomorrow. Let me give a quick recap of that, and then I will do the remaining part. Okay. Screen is not visible. Is it visible now? Can you able to see? No. Why it is like that? Just give me a moment. Can you able to see now, students? Is it visible now? Yes. Okay. So the important topics that we cover here in this lesson are the classical concept, electron transfer concept of redox, oxidation number, types of redox reactions, and oxidation number method and half reaction method. These 2 methods are used to balance the redox reaction. Okay. And at last, we will see the electrochemical process. So these are the 7 topics that we are going to see. So moving on to the classical concept of redox. Redox means it is all, we all know that reduction, both reduction and oxidation taking place in a reaction simultaneously are called as redox reactions, right? Now, coming to the classical concept of redox, yeah, the definition for oxidation and reductions are given like this. So the oxidation means addition of oxygen or removal of hydrogen, addition of electronegative element, removal of electropositive element. So just the opposite is for reduction. Removal of oxygen, addition of hydrogen, removal of electronegative element, and addition of electropositive element. Okay, this you might have studied in your yesterday's class. Okay, so one example is given here. So this is an example for oxidation. So here you see, so potassium, we have potassium, 4 potassium in the reactant side, and one of the potassium is removed. So potassium is basically an electropositive element. Okay, so the removal of electropositive element leads to the oxidation of the metal ion. So you see the oxidation number here. For iron it is +2, and here for iron it is +3. So +2 to +3. So there is an increase in the positive charge. Increase in the positive charge means it is called as oxidation. Okay, so oxidation is otherwise called as the removal of electropositive element. Okay, so this is an example to understand this particular definition. Now coming to the second topic, that is redox in electron transfer. So according to electron transfer concept, oxidation means loss of electrons. Okay, so in the previous example also we have seen, no, Fe2 plus has been converted to Fe3 plus. So with the removal of 1 electron. So loss of electron means it is called as oxidation. Okay, so gain of electron is called as reduction. Gain of electron is called as reduction. So here you see we have a sodium atom, and here we have a chlorine atom. Sodium will lose its electron and chlorine will gain that electron. So sodium will become like sodium plus, and this will become Cl minus. So sodium has got oxidized and chlorine has got reduced. Got it? So this is how we define oxidation reduction in terms of electron transfer. Instead of using oxygen and hydrogen, in terms of electron transfer concept, oxidation reduction is defined like this. Okay. So this is the second topic of this lesson. Now, moving to the third topic, all these you might have studied. You have studied yesterday. So coming to the third topic, that is competitive electron transfer. So scientists have done 3 experiments. Okay. So here in experiment 1, so a scientist have took the zinc rod and he dipped this zinc rod into the copper nitrate solution. Okay. And reaction occurs over there and zinc nitrate is being formed and the copper is there. Okay. Now, the observations that are made in this reaction are the zinc rod turns brown. Zinc rod is turning brown and this copper nitrate solution is there. No, it is turning colorless. Okay, solution is becoming colorless. So, this color change, the color change denotes that a reaction is happening inside the container. Okay, and that reaction is nothing but a redox reaction in which both reduction and oxidation takes place. So, in the zinc rod, 2 electrons are lost and it is getting converted to zinc 2 plus. And the copper 2 plus ion, which is present there in copper nitrate solution, so that is gaining the 2 electrons, which the zinc has given out, and it is getting converted to copper metal. Okay, so oxidation, loss of electron. Here zinc is getting oxidized and copper is getting reduced. Okay, so redox reaction is occurring. So here from this reaction, we can say that zinc metal is able to displace this copper metal. Zinc is able to displace copper. But in the second experiment, you see, we have a copper metal, copper rod, and it is dipped into the zinc nitrate solution. Okay, but here if you see, there is no reaction. So these 2 products are not formed. These 2 products are not formed. So why it is not formed? Why there is no change? Why there is no color change? So there is no reaction occurring over there. There is no redox reaction happening inside the container. So because copper cannot oxidize zinc. So zinc can oxidize copper, okay, but copper cannot oxidize zinc. So zinc can able to displace copper, but copper cannot displace zinc. So that's why in the second experiment, reaction is not occurring. Okay. Now coming to the third experiment, here you see copper is dipped into the silver nitrate solution. Now, instead of taking zinc nitrate solution, we are taking silver nitrate solution and we are trying to dip this copper metal rod inside this silver nitrate solution. And here reaction is occurring and this copper is able to displace the silver and we are getting silver out and copper nitrate is coming out as a solution. Okay, and here copper rod, this copper rod is turning its color to gray and silver nitrate solution is turning to blue color. Okay, so the reaction is occurring and copper is oxidizing, getting oxidized and silver is getting reduced. Okay, so there is an increase in oxidation number, right, from 0 to +2. So it is getting oxidized and here +1 to 0. So silver is getting reduced. So what do we understand from this? So all metals have varying tendency to release electrons. Okay, so in the first reaction, if you see, zinc is displacing copper. And the second experiment, copper is not able to displace zinc. But in the third experiment, copper is able to displace silver. Okay, so each metal is having some different tendency to release its electron and to get oxidized. Clear? So the order of release of electrons will be, this is actually yes, order of release of electrons will be zinc. First of all, zinc is able to release more, electrons easily and then comes copper, then comes silver. Okay. So this type of, this order is called as electrochemical series, or we can say this as metal activity series. So zinc is more reactive in releasing the electrons, we can say, and then comes copper, then comes silver. Okay. So you have to study this order. This order is very important. Okay, this order is very important. Okay, zinc is more reactive in releasing the electron compared to copper and silver. So that's why zinc was able to displace copper, but copper was not able to displace zinc. Okay. So this is about the competitive electron transfer. The competition between the metals is occurring now. So that's why we call this concept as competitive electron transfer concept. Okay, the more reactive metal is able to displace the less reactive metal, whereas the other way around is not possible. Okay, shall we move on to the next concept? Shall we move on to the fourth topic of this lesson? So do any of you have any doubt from this? From classical concept, from electron transfer concept, and from competitive electron transfer? No doubt. Okay, so the next concept is oxidation state. So what is an oxidation state, or what is oxidation number? So the charge on the atom in bonded state or free state or ionic state is called as oxidation state. So an atom is there. It can be in the bonded form, it can be in the ionic form, or it can be the free state. So there will be one charge acquired by that atom in any of these forms. Okay, so that charge is called as oxidation number. Or otherwise, we can state this oxidation number as it is the charge, real or imaginary charge, which an atom appears to have when it is in chemical combination. Chemical combination means when an atom is bonded with the other atom. Okay, that is called as chemical combination. No, so when they form a compound, so that we call that as chemical combination. So in that state, they acquire, an atom will acquire a charge. So that charge can be real charge, or we can say that charge is imaginary charge. So that charge is oxidation number. Okay. Now, how this charge is developed? How this charge is developed? Suppose if I'm taking NaCl, we write NaCl as Na plus and Cl minus. How this charge is getting developed? Plus minus charge is getting developed. No, how? Because of the electronegativity difference between the two atoms. Who is more electronegative here between sodium and chlorine? Who is more electronegative, students? Can you tell me which element is more electronegative among sodium and chlorine? Sodium or chlorine? Which is more electronegative? Which is more electronegative? Yeah, which is more electronegative? Ramnagar students, tell me. Very good. Chlorine is more electronegative. So more electronegative atom, what it will do? It will try to pull the electron towards itself, right? So it always acquire the electron, and it is taking the negative charge. So this is how a charge is developed between the two atoms. Okay. Now some of the terms we need to understand. Oxidation, reduction, these two terms we already know. Oxidation is loss of electron and reduction is gain of electron. So these two terms are a little bit new for you. So oxidizing agent and reducing agent. So who is an oxidizing agent? The one which is accepting the electron. The one which is accepting the electron is called as oxidizing agent, and the one which is donating its electron is called as reducing agent. Okay, suppose if I am having what I can say, okay, I'll take the A. Okay, A is reacting with B to give some product C and D. Okay, so now if I'm saying this B as an oxidizing agent, what it will do? This B atom or B element will go and take the electron from A. Will go and take the electron from A. So we call that element B as oxidizing agent. Okay, now A is donating its electrons to B, right? So A is a reducing agent. A is a reducing agent. Okay, so you will understand this when we go through this with an example in the upcoming slides. So you don't have to worry. So for now, you need to know what is an oxidation state and how the charge is getting developed when an atom is bonded with the other atom. Okay, now coming to the rules. Coming to the rules to find out the oxidation state of an element. Rule number 1 is the oxidation number of an element in free or uncombined elemental state is 0. Suppose if I'm having atoms like sodium, then what I can take? Yeah, single copper, metal ion, magnesium. So all these elements are present in the free state. They are not bonded with any other atom, right? So only one atom we have, that is sodium. Here also only one copper we have. Here also only one magnesium we have. So they are all in the free state. So an element in its free state have an oxidation number 0. Okay. So all these elements will have 0 oxidation state. Now they can also combine with the other atom, but it should be the same atom. The combined atom should be the same atom. Suppose here you see, we have fluorine. So fluorine is like this, no? Fluorine molecule, we draw fluorine molecule like this. So fluorine is bonded with the same fluorine. So both the atoms are same, electronegativity value will be same. So there won't be any charge separation between these two atoms. So there is no plus minus charge separation. So oxidation state is 0. Okay. Suppose for chlorine, for oxygen, for nitrogen, for ozone, and for phosphorus, and for sulfur, if you take any other elements like this, they all will have 0 oxidation state. Okay, if an atom is bonded with its same atom, then the oxidation number of that particular element will be 0. Okay, so this is rule number 1. Now coming to rule number 2. For alkali metals, who are alkali metals? Alkali metals belong to which group, students? Group number 1, right? Group number 1. So group 1 elements are alkali metals in the periodic table. And who are those metals? Lithium, sodium, potassium, rubidium, cesium, and francium, right? So these elements are group 1 elements. And if you see the outermost electron present inside this atom, the outermost electron will be 1, right? The general electronic configuration is NS1. So they can give out only 1 electron. So all the alkali metal group 1 elements will have +1 oxidation state, only 1 oxidation state. And if you go for alkaline earth metals are group 2 elements. Who are group 2? Beryllium, magnesium, calcium, strontium, barium, and radium. So these elements are group 2. So they will have 2 electrons in their outermost shell. So they will donate those 2 electrons and they will attain the stability. So the 2 electrons are lost, and that's why the oxidation number attained by this alkaline earth metals are +2. Okay. Now coming to rule number 3. Oxidation number of hydrogen is generally +1. Okay, when the hydrogen is bonded with the non-metal. When hydrogen is bonded with the non-metal means the more electronegative element, right? The right side element, the elements which are present in the right side of the periodic table, they are actually the non-metals, and we call those non-metals as more electronegative element. And those, when hydrogen is bonded with those electronegative element, hydrogen will have +1 oxidation state. Suppose, for example, okay, I'll take H2O. Now here you see, hydrogen is bonded with oxygen. Oxygen is a non-metal and it is the more electronegative element. So in that case, hydrogen will have +1 oxidation state. Okay, but when it is attached to least electronegative element, least electronegative means the elements which are present in the left side of the periodic table. So who are those elements? So these group 1, group 2, group 3. So those elements are least electronegative elements. Suppose if I take, sodium I'll take, okay. Sodium hydrate. Now here hydrogen is bonded with the least electronegative element, sodium. So in this case, in this compound, hydrogen will have -1 charge. So Na plus H minus. Like this only we will write, no? Na plus and H minus. So here it is attaining -1 and here it is taking +1. Okay. And coming to the 5th point, fluorine. The first most electronegative element in the periodic table is fluorine. Okay. So it always gains the electron. It never loses its electron. Since it always gains the electron, it will gain only 1 electron. It will always gain, but it will gain only 1 electron. So the oxidation state gained by fluorine is -1 in all its compounds. Oxidation number of fluorine is always -1. Okay. So any doubt from the first 5 rules? Any doubt from this first 5 rules you have? All the element will have 0. Alkali metal +1, alkaline earth metal +2. Coming to hydrogen story. More electronegative element when it is bonded, it is +1. And if it is least electronegative, hydrogen will have -1. And for fluorine story, it is always -1. Okay. Now next we will go into the oxygen story. The oxidation number of oxygen is -2 in most of its compounds. Okay. Except in peroxide, superoxide, and oxides of fluorine. Okay. Generally, it is taking -2. But in case of peroxide, H2O2, hydrogen peroxide, sodium peroxide, in all these peroxides, the oxidation state of oxygen is -1. Suppose, let me draw the structure here, okay? H2O2 is like this. Now, take this bond. Who is more electronegative? Oxygen is more electronegative. So, we have one bond. So, oxygen will gain that electron, hydrogen will lose that electron. And when you take this bond, both the atoms bonded here are same. Both are oxygen. So, there is no charge separation. Okay. When you take this third bond, oxygen will have -1 and hydrogen will have +1. So, each oxygen here it is taking -1 charge. So, that's why we are saying that oxygen is having -1 charge in its peroxide. Okay, peroxide. Then coming to superoxide, potassium, KO2, RbO2, these are superoxide. Here, one potassium is shared with 2 oxygen. One potassium is shared with 2 oxygen. KO2, if I take, I will draw like this. No. So, potassium will have only +1 because it is group 1 element. No, so it will be +1. And if you go for oxygen, +1 has to be divided into 2. So, how we divide +1 into 2? By half, minus half and minus half plus half is 1, right? So, we'll have -1. So, +1, -1. So, there will be neutral. Okay. So, each oxygen is having -1 charge, -1/2 charge. Okay. So, peroxide will have -1/2 and superoxide will have -1/2 and peroxide will have -1. Okay. Then coming to oxides of fluorine. Oxides of fluorine. We have only 2 compounds. One is O2F2 and the other one is OF2. Now coming to O2F2. O2F2 structure is same as that of H2O2 only. So this is O2F2. And here if you see with respect to this first bond, oxygen and fluorine are bonded with each other. Fluorine is more electronegative. Right. So what this fluorine will do? It will try to gain the electron from oxygen and oxygen will lose its electron. Now when you take this bond, as I have already told you, both the atoms which are bonded in that bond are same, though no electronegativity difference. There is no charge separation. When you take this bond, we have one fluorine and again that is more electronegative. So it is -1 and here it is +1. So since oxygen is losing its electron, it is taking +1 charge. So each oxygen is taking +1. So that's why the oxidation number of oxygen in O2F2 is +1. Okay. And coming to OF2. OF2. We have 2 bonds and both the atoms are fluorine. Okay. So here it will gain and here it will lose. And with respect to this bond, fluorine will gain and oxygen will lose. So oxidation number, the charge acquired by this oxygen is +2. Okay. So only when oxygen is bonded with fluorine, it will have a number, oxidation number, and it will have positive oxidation number. In all other cases, it will have negative values only, but that negative value will change for peroxide and superoxide as -1 and -1/2. Okay. Rest all other compounds will have -2 as the oxidation number for oxygen. Is that okay? Yeah, coming to the 7th last point of this rules, the sum of oxidation number of all atoms in a species is equal to the net charge on the species. Suppose here you see K-metaphor is taken as an example. We are calling this molecule as neutral. Why it is called as a neutral molecule? So add all the charge. Potassium means it is a group 1 element. So it will be +1. Okay, potassium will have +1 charge. And coming to manganese, manganese will have +7. Okay, 7 electrons will be there. So it will be +7. Okay, and for each oxygen, we have to give -2. We have 4 oxygen. So 4 into -2 is -8. So now if you add everything, we will have 8 - 8 and that is equal to 0. So sum of the oxidation number will be equal to of all atom in our species is equal to the net charge on the species. Okay. So that's all about the rules. So here this oxygen story is very, very important, and the hydrogen story is also very, very important. Okay. So students, any doubt you have? Is everything clear up to this? Shall we move on to the next part? So these are the rules you have to follow to find out the oxidation number of an element, not only in this lesson. For all your chemistry lessons, you have to follow this. Okay, these are the basics to your inorganic mainly. Okay, so the next topic is types of redox reaction. I think the types of redox reactions was covered yesterday by Vivek sir. Am I right? Has he covered these types of redox reactions? Yes or no, students? Have you studied this yesterday? Combination reaction, decomposition reaction, displacement. Yes. So shall I skip this and move on to the next topic? Shall I? Say yes or no? Okay then. So combination is combining the two atom. Okay, two atom or two element will lead to a product. Okay, these are the examples of redox combination reaction, and here it is decomposed. One compound breaking down into two or more than two is called as decomposition, in which both reduction and oxidation occurs. And there is one exception here, that is calcium carbonate. So that part we have studied. And this is the displacement. In competitive electron transfer concept, we have discussed this, no? So this is the metal displacement and non-metal displacement concept. Both are redox reaction only. And the last reaction is disproportionation reaction. Okay, what is disproportionation? Atoms, molecules, or ions having more than two oxidation state simultaneously. So here in this case, what we have? Oxidation number of hydrogen is +1. And for oxygen, here it is peroxide. So in peroxide, oxidation state of oxygen is -1, right? So -1. And here in water, it is -2 +1. And here this oxygen is present in elemental form, so it is 0. So oxygen is going from -1 to -2 in one case, and from -1 to 0 in the other case. -1 to -2. What it is? Decrease in the oxidation number, going towards the negative side. So this is reduction. And -1 to 0 means it is oxidation. Okay. Same element will get oxidized as well as it gets reduced. So those reactions are called as disproportionation reaction. Okay. So here also in this example, if you take phosphorus, here it is 0 because it is in the elemental form. And in case of phosphine, this pH3, if you take +1, so 3 into +1, and this is -3. And here, if you take here +2, +x, and -4, +1 equal to 0. So x is equal to 4 minus 3, which is equal to +1. Okay. So 0 to -3 in one case. 0 to -3. So this is reduction, and 0 to +1. So this is oxidation. Okay. You just remember this number line, which you use in maths. So in number line, we have like this, no? So -1, -2, -3, it goes on like this. If you're going from negative side to positive side, this is oxidation. So here this is reduction. So here 0 to +1. 0 to +1 means it is oxidation. Okay. And 0 to -3 means it is going towards left. No, so it is reduction. So this is reduction. So is that fine, students? I'll move on to the next topic, that is balancing the redox reaction. So redox balancing mainly involves the balancing the atoms, balancing the charges and the electrons lost and gained. Okay. So we have to balance all these things. We should not balance only the atoms and can come out. We have to balance the charges and also the electrons lost or gained. Okay. So here we have two methods to balance the redox reaction. The first method is called as half reaction method. So here what we do, equations are balanced by dividing it into two half reactions. So we are dividing an equation into two half reactions. One is oxidation half reaction and the other one is reduction half reaction. So that's why we call this method as ion electron method. Okay, ion electron method is the other name for half reaction method. Now let's see the steps. Okay, let's see the steps that are involved here in this method, and then we will, with an example, we will discuss those steps. I'll take this equation as an example. So step number 1, what you have to do. First of all, this particular reaction will be given to you in the question. Okay, so you have to just write the ionic equation first. Okay, and then we have to divide this reaction into two, like oxidation half reaction, reduction half reaction. So how to know that? First of all, we need to find out the element which is getting oxidized. So here you see Fe2 plus is getting converted to Fe3 plus. So increase in the positive charge means that is oxidation. And here for chromium, if you take plus 6 is the oxidation state and here plus 3. So that is the reduction half reaction. Okay. So now I have divided this reaction into 2. Now the third step is you have to balance all the atoms except oxygen and hydrogen present in the both the reaction. Okay. So take the first reaction. We don't have oxygen and hydrogen. Okay. And taking the second reaction, and it is already balanced. Fe is already balanced. We have only one Fe on both the sides. So that is already balanced. Then coming to the reduction half reaction, if you see, we have oxygen. Okay. Now, for now, we don't have to take that oxygen into account. And apart from that, we have chromium. We have 2 chromium in the left-hand side, only 1 chromium in the right-hand side. So what I have to do, I have to put 2 here to balance the chromium. Okay, now I have balanced all the atoms except oxygen and hydrogen. Now, in the fourth step, if the medium is acidic, how do I know that the medium is acidic or not? They will give that information to you in the question paper itself. Okay, you don't have to worry. So if the medium is acidic, we have to add H plus and H2O to balance this hydrogen and oxygen. Okay, so now I'll take this reaction. I have 7 oxygen here. So what I have to do, I have to add 7 water molecule. Now I have 7 into 2, 14 hydrogen. So in the left hand side, what I will do, I will put 14 H plus. I'll put 14 H plus. Now I have added H plus and H2O and I have balanced the hydrogen and oxygen also. So I'm getting this reaction at the end. Okay. Now all the atoms are balanced. Okay, all the atoms. This is the oxidation half reaction. Atoms are balanced. And coming to the reduction half reaction, all the atom, chromium, oxygen, hydrogen, everything is balanced. Now that is not enough. Charges also should get balanced, right? So to balance the charges, what they are doing, they are adding electron. So how do I know how to calculate the charge first? So let me erase everything that is there on the slide so that you can see in a better way. So now let me calculate the charge. So take this half reaction, reduction half reaction. So 1 into minus 2 is minus 2. Okay. So here 14 into plus 1 is plus 14. 2 into, in the right hand side, 2 into plus 3 is plus 6. And 7 into 0 is 0. Okay, neutral, no? So it is 0. Now in the left hand side, the total charge, what is the total charge? 14 minus 2. 14 minus 2 is plus 12. Okay. The right hand side, I'm having plus 6. So left hand side, I'm having 12. Right hand side, I'm having 6. Now the charge is not balanced. So what I have to do, I cannot do anything in the right hand side. I can do something only in the left hand side. Okay. So to bring this 12 to 6, I have to add electron. To bring 12 to 6, what I have to do? I have to add 6 electron. If I add 6 electrons here in the left hand side, 6 into charge of an electron is negative, right? So 6 into minus 1 will be minus 6. So 12 minus 6, now it will be plus 6. Now the charge is balanced on both the sides. Clear? So that's why we are adding 6 electron in the left hand side here. Okay. If 6 electrons are gained in the reduction half reaction, 6 electrons should be lost in the half reaction, oxidation half reaction, right? So for that purpose, what I am doing, I am multiplying this oxidation half reaction by the number 6. So if I multiply that by 6, I will have 6 Fe2 plus and 6 Fe3 plus and 6 electron. Now the common terms are 6 electron, cancel out each other and write the remaining thing. 6 Fe2 plus, CrO7 2 minus, 14H plus, giving 6 Fe3 plus 2 Cr3 plus and 7 H2O. So this is the balanced redox reaction. Is this clear for all? Any doubt you have? Do any of you have any doubt from this part? Write the given equation, divide it into 2, balanced all the atom except oxygen and hydrogen. Now to balance those two, add H plus and H2O according to the medium. Okay. Then balance the charges by adding corresponding electrons or protons according to the equation. Then cancel out the common terms and write the remaining ions and molecules in the final equation. That's all. Okay. So in the NEET exam, what they will do, they will ask you to find out this coefficient. Okay. They will ask you to find out this coefficient. 6, 1, 14. So that we have to find out. Only if we balance the equation, we will get those numbers, right? So that's all. Now coming to the next method, oxidation number method. So this is the other method to balance the redox reaction. You can use either one of these two methods. Okay, both the method will give you the correct answer. Now this method is based on the change in oxidation state of the oxidizing and reducing agent. So as usual, what you do, write the reaction with proper formula that is given in the question paper. Okay. Now assign oxidation number to all data. Find out the oxidation number. So chromium plus 6, oxygen minus 2, sulfur plus 4. You all know how to find out the oxidation number, right? Or you want me to teach that how to find out the oxidation number? So I'll teach for this SO3 2 minus. Okay. So if I want to find out the oxidation number of sulfur, I have to take the sulfur as X. And for each oxygen, the charge is minus 2. Since I have 3 oxygen, it is 3 into minus 2, minus 6. Okay. And the charge is minus 2. So put that here. Okay. Equal to minus 2. Now X is equal to minus 2. Okay. I'm teaching my dear students. I'm teaching. Okay. Once again, I'll start from the first. Okay. So I'll take Cr2O7 2 minus. Now I have to find out the oxidation number of chromium. Okay. And here I have 2 chromium. So what I have to do, I have to put 2x. Okay. And the charge of oxygen is minus 2. I have 7 oxygen here. So 7 into minus 2 is minus 14, which is equal to the charge. The charge of this complex is minus 2. No, put that number to the right side of this equal to symbol. Okay. So this is how you have to start. Then find out the value of x. 2x is equal to minus 2 plus 14, which is equal to plus 12. And x is equal to 12 minus, divided by 2, plus 6. So plus 6 is the oxidation number of chromium. Okay. Understood? Or any doubt you have? Shall I solve this SO3 2 minus? Yes? SO3 2 minus is the compound. Sulfur is taken as X, and for each oxygen it is minus 2. So we have 3 oxygen. So 3 into minus 2 is minus 6. And also we have the charge for this compound that has to be written right to the equal to symbol. So X is equal to minus 2 plus 6, which is equal to plus 4. Okay, so that is the charge of sulfur in SO3 2 minus. So in the same way, if you calculate, here we have already plus 3. And here if you take X, 4 into minus 2 is minus 8, which is equal to minus 2. So X will be equal to plus 6. Minus 2 plus 8 is plus 6. So that's why we are writing plus 6. Is that okay now? Fine. Shall I go with the third step? So now I have assigned oxidation number to all the good. Now I have assigned oxidation number to all the elements given in the equation. Now my next step is calculate the increase and decrease in the oxidation number of each element and equate both sides by multiplying suitable number. Now, if you see the oxidation state of sulfur, sulfur is moving from +4 to +6 and chromium is moving from +6 to +3. Keep this in mind, okay? So sulfur is going from +4 to +6 means it is losing 2 electrons, and chromium is going from +6 to +3, that is chromium is gaining 3 electrons. So what I have to do, I should multiply chromium by 2. I just have to cross multiply this. I should have 2 chromium and 3 sulfur in my equation. Okay, so multiply chromium by 2 and sulfur by 3. So what I will have here, I am already having 2 chromium. So in the right hand side, I am multiplying by the number 2. Okay, and I should have 3 sulfur. So I am putting 3 in both the sides. Okay, so this is what I have done. And after adding these numbers, and we have to balance the charge. We have to balance the charge. So after adding these numbers, what equation I will have? That equation is not written here. So let me write the desired equation that comes after the step 3. So we will have Cr2O7 2 minus plus 3SO3 2 minus giving 2 Cr3 plus and 3 SO4 2 minus. So this is the equation we get from step 3. Okay. Now all the atoms are balanced. Next step is to balance the charges, right? Now calculate the charge. 1 into -2, -2. 3 into -2, -6. 2 into +3, +6. 3 into -2, -6. Now in the left hand side, -2, -6, -8. In the right hand side, +6, -6 is 0. So right hand side charge is 0, but in the left hand side, I'm having -8. So in the right hand side, I cannot do anything. I can alter only the left hand side part. So I have to bring this -8 to 0. So what I have to do? I have to add 8 proton. Okay. Plus 8 H plus. So 8 into +1 will be +8. Now this -8 and +8 will be equal to 0. Okay. If you want to add negative charge, add electron. And if you want to add positive charge, add proton. Okay, that's all. Now the charges are balanced. Now if you see to the oxygen atom. So in the left hand side, we have balanced this equation and we have got this equation. Okay. Now, if you look into the oxygen, it is not balanced. In the left hand side, we have here 7 oxygen and here 3 into 3, 9. So totally we have 16 oxygen in the left hand side. In the right hand side, 3 into 4 is 12. Only 12 oxygen atom we have. To balance this oxygen, we are adding H2O in the right hand side. Okay. So in the right hand side, 4 more oxygen is needed. So I am adding 4 H2O molecules. And after adding this H2O, check with the hydrogen also. So 4 2s are 8 hydrogen here. And here also we have 8 H plus. So hydrogen is balanced. Oxygen is balanced. Sulfur, chromium, everything is balanced. And here the charges are also balanced. Now the equation is balanced. Clear? This is the oxidation number method. Is that okay for all? Clear? Any doubt from both the methods? You have to go through and solve and practice more questions. Like in your book itself, you will be having some 4 to 5 questions in the exercise part as well as in the example side, you will have questions. So practice those questions. You will get used to it and you will not make any mistake. Okay? You don't have to worry. You can get the answer so quickly if you have practiced this. Got it? Shall I move on to the next concept? The last topic of this lesson. Shall I? Okay. Applications of redox. Now, what are the applications? What we are going to do with this redox? First of all, we can find out or determine the equivalent weight using the redox reaction. What is meant by equivalent weight? The mass of an element which can combine or displace is called as equivalent weight of the element. Okay, the ratio of molecular weight and number of electrons gained or lost will give the equivalent weight. So this is the molecular weight. Number of electrons lost or gained can be written as n factor. Okay, so the ratio of these two will give the equivalent weight. So this formula is very, very important. What is n factor? Number of electrons lost or gained in a molecule is called as n factor. Okay, I will show you some examples. So, okay, take this KMnO4. KMnO4 in acidic medium is getting converted to Mn2 plus. Now the oxidation state is +7 here because potassium will have +1 and the manganese is taken as X and oxygen is -2. So 4 into -2 is -8, which is equal to 0. So X will be equal to +7. So +7 is the oxidation state of manganese, and in acidic medium it is moving to +2. So +7 to +2 means 5 electrons are gained, right? So the number of electrons gained is nothing but n factor, and that is 5. Now substitute this number 5 in the equivalent weight formula. So equivalent weight will be equal to molecular weight of KMnO4. You all know how to calculate the molecular weight, right? Sum of the atomic weight will give you the molecular weight. Okay, and divided by n factor, that is 5. And here in basic or neutral medium, you see 7 plus 7 2 plus 4 means 3 electrons. 3 is the n factor. So put 3. And in strongly basic medium, +7 to +6. Only 1 electron is gained. So n factor is 1. It is not 3. It is actually 1. So n factor is 1. Okay, molecular weight is equal to equivalent weight because the n factor is 1 in case of strongly basic medium with KMnO4. Okay, so we are able to calculate the equivalent weight in from a redox reaction. This is the very main application. Then coming to the redox titration, a technique which is used to determine the unknown concentration against a known concentration is called as redox titration. So we will have an oxidant and a reductant. Okay, the strength of oxidant and reductant can be calculated using this redox titration. So there are few terms, 2 terms, important terms we have. One is titer. So that is a substance whose concentration is to be determined. Okay, titer is the substance which is in which the concentration is going to be determined. Okay, so here I have a burette and I have a stand here, and then it is connected with a conical flask. Okay, so solution which is there in this burette is KMnO4. You can see a purple color solution, right? So that is the potassium permanganate solution, and it is titrated against the oxalic acid. Oxalic acid is present in this conical flask, and here we are doing the titration. You might have gone to your lab and you might have done this reaction. Okay, so it is titrated and some color changes are observed, and in that point they will stop the reaction. All these things are related to your practical chemistry. You will be doing this in your labs. Okay, so those reactions are redox titrations. So we have a titer over there, and then we have a titrant. So the one which is present inside the conical flask is called as titrant. So oxalic acid is a titrant and KMnO4 is a titer. Okay, so titrant is the substance whose concentration is known. Means we already know the concentration of oxalic acid, and the concentration of oxalic acid which is already known is used to determine the concentration of the KMnO. Okay, so we call this reaction as KMnO4 versus oxalic acid titration. Now, how to know the endpoint? How to know the endpoint? So we need to know the endpoint, right? We will find out the endpoint by using the color change. By using the color change. So here KMnO4 is a self-indicator. KMnO4 is a self-indicator. So when you titrate this KMnO4 against this oxalic acid, the solution will be colorless. And if once the reaction stops, the colorless solution which is there in the conical flask will be converted into pale pink color. So that is the end point of the reaction. Okay, so that pale pink color indicates us to stop the reaction. Okay, to stop the titration. So that is the end point. So this is how we can find out the answer, and it is indicated by a color change. So I'll show you the setup also. So here is the setup. This is the burette, and in the burette only we fill the KMnO4, and we have a stopcock, stands are there, and this is the unknown solution. Okay, titration flask. So we have two different types of indicator, self indicator and external indicator. So I told you, no, KMNO4 is an example for self indicator. So it is one of the reactant, and that reactant itself is telling us the color change. So it is acting as an indicator. Okay. And external indicator means you have to add externally. Okay. Diphenylamine, methyl orange, phenolphthalein. So these are the substance which is used as an external indicator. So if in the conical flask, I may have a solution. And to the solution, in addition to this, I will add some indicator. So that indicator only will tell me the color change. Okay, those are external indicators. So with this, the redox reaction lesson is getting over. So if you are having any doubt, you can bring those doubts in the next class. If you are having any small doubt, you can ask me. So with this, the redox reaction lesson is getting over. It's a very, very, very small lesson. Okay, only the types of redox reaction part we didn't see properly because it has already been covered yesterday. That's why I didn't go through it. So if you're having any doubt or facing any difficulty in any of the topics of this lesson, you can bring it to me. Okay, in the next class or in the upcoming sessions. So in the next session, we will go with the new lesson, the other lesson. We will go with GOC. We will go with general organic chemistry lesson. Is that okay? Only GOC and hydrocarbons are left, right? Other lessons are over, I think. Am I right? JNV Ramnagar students? Yes. Okay, okay. Fine, fine students. I'll meet you all with the GOC lesson in the next session. Thank you so much for listening to today's lecture. Okay, thank you. Take care. Bye. Bye-bye. Don't waste your time. Sit and study properly. Yeah.